Welcome, everyone. Thank you for joining us for today's webinar, Egyptian PSM Standards Implementation, presented by Wayne Repig, Robert McGraw, and James Birch. Now, for today's webinar, I want to go over a few housekeeping items. First, we want to respond to your questions following this webinar. Please type questions into the Q&A box in the Zoom control panel, and our presenters will respond to the questions. Finally, at the close of our webinar today, please provide feedback by responding to our survey. We're excited to have Wayne Repig, Robert McGraw, and James Birch presenting this morning. So, without further ado, I will turn the time over to Wayne.
Thank you, Joanna, and good morning to everyone in Egypt, in Cairo, from Alexandria to Sokna and everywhere else. It's great to finally be here. This has been a long time in the making for BakerRisk, and we are excited to finally be presenting what we hope to be the first in a ongoing series of webinars regarding Egypt's PSM standards and guidelines. So a couple of things. Let's first show you the agenda that we have here. This is what we're going to be going over. Basically, a little bit about BakerRisk. I don't want to talk at great length about BakerRisk. You'll learn more about us in coming weeks and months. Really want to get to the meat of the webinar, which is James and Rob speaking. So the three presenters, you've got myself, we have Rob McGraw, who's the operations manager in UK. Rob, go ahead and say hello.
Good morning, everyone. Pleasure to be here, and I hope you find what we have to say this morning of interest. Look forward to it. Thank you.
Thanks, Rob. Rob is one that was very active on the PSM technical subcommittee's peer review process, very actively engaged in that over the last couple of years. And then another SME that we have on is James Birch, who is certainly no stranger to Egypt. James?
Good morning, everybody. We're glad to be on, the opportunity to share this with you today, and hopefully engage some questions as we go through. So really looking forward to that. Thank you for joining us.
Great, thanks, James. I know both of them are no stranger to a lot of you in Egypt, and you'll certainly be seeing a lot more of them as we move forward. Okay, so BakerRisk, you know, our whole purpose for existence is largely the reason why you're here as well. It's really just to save lives and make the world a better place for what we do in our various industries. That's it, plain and simple. A little bit about BakerRisk. So we are based in Texas. San Antonio is our corporate headquarters. Houston is where I am based. That's one of our large offices as well. Founded in 1984. So in January, we're celebrating our 40th anniversary. We have a staff of over 200, 125 engineers and scientists throughout the world, 2 test facilities in Texas. One is, both are outside San Antonio. One is called Skull Crossing, about 65 hectares. The other is known as Box Canyon, 931 hectares. And this photo on the right-hand side was taken at Box Canyon. You'll see that, and you'll also see some videos later on, hopefully they'll run smoothly, of tests and research and a lot of explosions that we've done at those test facilities. We also have a materials lab where we do a lot of testing for our incident investigation. And then we run several different joint industry programs, which I'll mention briefly in a moment. So global operations, we've completed projects in 50 countries, clients on 6 continents. The offices we have, again, San Antonio, Houston, which is where I am based, Chicago, Illinois, and Los Angeles. Those are all in the US. We have an office in Toronto. We have an office in the UK where Rob and James are based. And we are pleased to say, as of last week, we are officially now BakerRisk Egypt. So we have an office in Cairo right now. So we're certainly looking to expand that further in the coming months and years. And in 2024, we look to be opening an office in the UAE as well. Okay, what we do. So we have 7 major areas, service areas, and then we have one wholly owned subsidiary, which is product oriented. The 7 areas that we have for services are process safety, and that's what Rob and James will be speaking about here momentarily. Structural response and blast effects. Now, those 2 categories are areas in which we gave a week-long course 2 weeks ago in Cairo for the capacity building program Wave 2. We also have another service area known as accident investigations. We have the BakerRisk Learning Center, where we offer a lot of training, both custom as well as scheduled. That's all on our website. We have our testing area, which is, as you see in the photo, that's one of our test sites. We have a software division, and then we have a products focus with our wholly owned subsidiary, Fortress Protected Buildings. So we're focused on predicting, mitigating, investigating, and testing. That's what we're all about. Rob, do you want to go into a little bit about our division?
Yes. So really, the purpose of this slide is to demonstrate how pretty much process safety is central to everything we do, and how the sort of journey into process safety management progresses. So the various boxes around the figure on the left, and then on the right hand side some fairly logical steps in terms of the obviously the first step is to set up your management system, so the process safety management system. James will be going into more detail about the implementation, but at this point we just really say you need to, before you can decide what you need to do to get to where you need to be, you need to work out where you actually are at present. So quite often the first task is some form of gap analysis, and then development of the various standards, guidance, and procedures to develop that system, to make it complete. And one of the key things again that James will be focusing on is the importance of leadership, senior leadership in all this. A program, a process safety management program, will be destined to fail at some point if there is not strong acceptance and leadership from the top of the organization. And of course, in any good management system loop, there is an audit and review loop. So once the system is set up, then you can actually get into the detail of doing the analysis. And then, so again, some fairly obvious first steps. The first thing you need to do is identify the hazards. What is it you need to be worried about? And clearly, this will vary significantly from business to business, activity to activity. And what we look at is general fire, explosion, and toxic threats. And that might be threats to personnel, so either workforce on the site, or members of the public, or other third parties off-site. There's also a focus on occupied buildings, and also increasingly we look at critical equipment in terms of a business continuity perspective. And then once we've identified those hazards, we'll then look at assessing how bad can it be. And then from that, what levels, what layers of protection you need in place to make sure that those events are happening at a sufficiently low frequency that the risk is acceptable. Which takes us on to the risk assessment step, to add some likelihoods, probabilities to the events we've identified, to give us a quantification the risk, and again that could be to personnel on off-site or to business impact as well. And then once you've got all that information, what do you do with it? Well, obviously the journey is to try and reduce those risks to your people, to the business, so that the analysis will help flag up a number of potential risk reduction options. Some may not be optional if you in certain conditions, and for each of those you can then do some form of analysis, usually some form of cost-benefit analysis, or it could be all sorts of different qualitative comparisons between one option and another, and then that then informs your improvement action plan, where you actually take action to reduce the risks that you're exposing the workforce and the communities to from your hazardous operations. So again, just it's all these activities are sort of sitting around that central process safety theme. Okay, Wayne, back to you.
Great, thanks, Rob. And you'll find that one of the areas that we're going to be really keying in on a lot, and you'll hear us speaking about it a lot, not just on this webinar, really is that first area, process safety management, PSM, which is so critical because it does take the buy-in of management, and it takes leadership to really to get this moving. So we tend to focus on that a lot and start off with that as a starting point, and then develop into the other areas that Rob went ahead and outlined here. Thank you, Rob. Okay, so getting back, I mentioned earlier our joint industry program. So we have several of those. These are programs where firms have basically funded research that they want to see. And we have a few different joint industry programs. One is known as the ERC, Explosion Research Cooperative, and a lot of the videos and photos that you'll see of some of the testing and explosions were done on their behalf. Another one we have is for pressure testing, and then another one which we've been I think active in for several years now, quite a while, is ammonia and fertilizer, focused on that industry. So those are known as JIPs, Joint Industry Programs. We have global members involved in all of those. We're also quite active in authoring and contributing to various CCPS guidelines and their books. The most recent one that just came out is Managing Abnormal Situations. I think we have another pending one coming out here shortly. James, I don't recall the name on the one that's pending. Do you recall that one?
Off
Maintenance and reliability.
It's returning equipment to service, maintenance and returning equipment to service.
Great, thank you, Rob. And then certainly validation testing for industry standards, API 752, 753, 756. Those are all in the process of being updated as well, and I'm told will be released imminently. But we're very actively involved in API and on a variety of committees as well. So where we work, obviously in the petrochemical area, in oil and gas is a big part of our clientele. Manufacturing, refining, legal, transportation, all those different industries are ones that we take part in throughout the world. It's fairly extensive anywhere there's hazard and risks in the industrial sector. And then at the bottom, some of the organizations that we are actively engaged in and sit on committees and have been for a number of years, and then conferences and working groups as well, fairly extensive. Okay, our commitment to the Egyptian PSM program. And I do want to thank from the ministry, Engineer Ala Hagar and Wessam Sakar and their staff for their cooperation, all of their support over the last year, not only in this webinar, but they've actually been quite good to work with and very receptive. I give the ministry a lot of credit for what they have set up here. We have the opportunity to view PSM programs throughout the world from various countries that have set it up. And I would say that one of the reasons that we are so committed to Egypt is that Egypt has done it right. It's probably one of the best that I've ever seen globally for a country that has set up a new program, and you've done it extremely well. You're continuing to do it extremely well with all aspects, with your capacity building program. So you should all be very proud of being a part of the industry in Egypt. We are certainly very supportive of each of you, and will continue to show our commitment as we have for the last several years. So our involvement started several years ago with the PSM technical peer review process. And I do want to thank Amr Hassan, who is an independent PSM senior consultant. He headed the technical subcommittee, and it was from his involvement that BakerRisk was brought in. And Rob McGraw pretty much got involved and kind of led a team of 10 or 11 people from BakerRisk on doing technical peer reviews over a period of time. And that really got us very much aware of what was going on and what was happening, and kind of kicked it all off. And from there, we had even greater involvement going forward in October of 22. And that's the photo that you see on the right side is from a reverse trade mission sponsored by the US TDA, where 15 delegates from the ministry's selection came to the U.S., and BakerRisk was honored to present to them a full-day program on PSM, on blast effects, occupied buildings by Dr. Kelly Thomas, and then also on facility siting, QRAs by Rafa Calais. That was in D.C. in October of 22. In February of 23, Rob McGraw also presented a paper, and we attended and exhibited at Egypt's 2023. Rob's paper was Hydrogen and Ammonia, a Tale of Two Gases. 2 weeks ago, as I mentioned earlier, we took part in the ministry's capacity building program, Wave 2. This was in Cairo, where Dr. Kelly Thomas spoke on blast effects, and Travis Holland spoke on structures design. So that was earlier this month. And then we established our office, as I mentioned also last week. That is now official. And then this is a kickoff of our webinar series. So this is the first one in who knows how many, but we're looking forward to continuing the series. We will be at Egypt's 24 next month, or I'm sorry, in February. We'll have another booth there as well with a team of us attending. So we hope you'll stop by and say hello as well. Okay, so this is, I'm going to hand it over to James.
Rob is going to run this bit through. So I think Rob's now got the.
I have control. Yep.
Very
Thank
good.
You. Thank you, Wayne.
Mm-hmm.
Yep. So the first question is, what is PSM? Why is it essential? Why is it important? Why are we investing all this time, effort, and money into developing standards for the companies in Egypt to take away and implement? Okay. So I'm probably preaching to the if you're on this webinar, you probably don't need telling this, but process safety management, high level definition, is the identification, evaluation, and control of the hazards associated with hazardous chemical processes. There are numerous different variations on that definition, whether you look at CCPS, OSHA, UKHSE, or the Egyptian PSM standards. But it all basically says the same thing. What we're trying to do, we're running processes that involve hazardous substances, and what we want to do is make sure that material stays in the pipe, and we keep the hazard under control. basically we're dealing with a wild animal like a lion, and we want to keep it under control. So if it's it may be in a cage, but it's still a lion. So we need to make sure we've got that material under control. Why is it important? Because when it does go wrong, it goes wrong. It can go wrong very badly. What you're seeing here is just a series of photographs of famous or infamous process safety incidents which have cost many lives, and have not only cost lives, caused environmental damage, but also from a brutal cost and business perspective, seen the end to many companies along the way as well. The examples showing there include many from onshore, upstream, downstream, midstream, chemicals, and other sectors, as well as offshore. Examples going back as far as 1947 to the SS Grand Camp, which was a ship that exploded containing ammonium nitrate in Texas City, and that killed 581 people and injured countless thousands of others, through to the famous Flixborough explosion in the UK in 1974. There was a cyclohexane explosion that killed 28 people, and was very much a catalyst for the whole process safety development. Moving further forward, we have incidents like the BP Texas City vapor cloud explosion in 2005 that killed 15 people, and again that very picture there that again highlighted the how easy it is to site temporary buildings in inappropriate locations. So a lot of the API work that Wayne referred to before resulted from Texas City explosion and controlling those temporary buildings, and the list goes on. Obviously, the offshore, we've got the Piper Alpha platform, multiple explosions and loss of the platform in the North Sea in 1988 that resulted in 167 deaths and major changes to the regulation and control of offshore development in the North Sea. More recently, we had the BP Macondo well blowout in the Gulf of Mexico. Killed 11 people and caused massive environmental impact with ongoing oil spills for several weeks after the initial explosion. So again, process safety management considers risks in many forms, business risks. So we're looking at health and safety, environmental, financial, and non-financial, particularly in this age of instant social media coverage. The impact on a company's reputation if it has an incident can be instant. So again, the importance of this is increasing. Okay, so what do we need to do? The key to this is understanding what can happen, and therefore what we can do to prevent it happening. As Wayne mentioned, we have various research and testing capabilities, and we use those to do that, to allow us to understand the processes that are taking place, and we do that to underpin the tools that we use for doing the analysis, and also a bit of sort of reverse engineering from the incidents we investigate to try and confirm potential theories on how an accident occurred. We can do tests to confirm whether that was a reasonable hypothesis. So from that understanding, we get the knowledge that helps us then assist our clients, assist you guys in preventing those that are occurring on your site. So this is a view of one of our test facilities, or part of one of our test facilities. This is Box Canyon. And again, in the subsequent slides, I'll go through a series of test videos that show how accidents can develop from that getting out of the pipe to impacting people, buildings, and other equipment. Okay, so the first thing we said is getting out of the pipe. So what does that look like? This. So this clip is it's not very exciting, to be fair. They do get better, but this shows what a release looks like. This is a propane being released from an orifice that is half an inch or sort of 10mm orifice, so a very small hole. And what I would say is this: the amount you can see, the visible amount, is just that bit there where the water in the air is condensing. The actual cloud itself is significantly bigger than than what you're seeing on from the vapor there. But bear in mind, this is propane, but equally this could be a toxic material, such as the methyl isocyanate that was released in the Bhopal incident. So again, you can see how this disperses from a small hole. If you can imagine, this hole is very similar to many connections, instrument connections or sample connections that might be on your main process pipework, that sort of small bore connection. And you could get this release into your operating areas, affecting personnel there. Okay, so if we have a release, what can subsequently happen to that? And this shows what can happen if you get a flammable release and it gets ignited. Again, we're talking a very, very small hole, half inch to 12 millimeters. And this particular example is gasoline. So that shows what if you get a release and it ignites fairly instantaneously. Another test at night shows it a bit clearer, and you can see that instant impact across several tens of meters. Another potential hazard we deal with is the vapor cloud explosions, and this occurs when you have a flammable release that isn't immediately ignited, and you get an accumulation of flammable material, which then ignites with a potentially much more destructive power. This is an example of one of our test rigs. The polythene on the outside is just to contain the gas up to a certain mixture. Again, this is a propane air mixture. And if you look in the center of that, you can see a sort of dark area where we have some congestion. So that's to simulate the plant and process equipment for the test. So I'll just show that again. I mean, in terms of vapor cloud explosions, there are many factors that affect the potential energy and impact of a vapor cloud explosion. The three primary factors being the material reactivity, which is a measure of how flammable a material is. Something like ammonia is very low. Low reactivity, very difficult to ignite. Whereas if you go to something like ethylene or polyethylene, that can result in very violent explosions. The other factor that I mentioned was the congestion. So the amount of obstacles in the way that cause the gas to cause turbulence and cause mixing that increase the explosion energy. And the third key factor is confinement. So if you're boxing that in any dimension, it's going to increase the forces that are acting. So as I said, we use various piping and other equipment to simulate congestion, but we also then validate against real equipment. So this was a mock-up of a plant unit where we wanted to validate our control tests against some real equipment that was very kindly donated by one of our clients for us to destroy. So again, this shows how the same we get the same impacts from our control testing with real equipment, and it allows us to validate the testing that we do. Flammable gases, toxic gases are not the only thing you may have to worry about. Dust explosions is another potential hazard for many operations. This particular test shows a release of polyethylene dust, and you can see the quite violent explosion that results from what many would think was a fairly innocent release of dust. And again, I'd mentioned about the impact of confinement on explosions. The same's true for dust explosions as it is for vapor cloud explosions. And this test rig has been boxed in. It's a solid rig with panels added on each end, and again a dust explosion generated inside. You can see how that causes explosion inside and blows the panels off the end again. So it's simulating, allowing us to simulate what would happen in a real condition with a building of a similar design. So we've looked at these various hazards. I mean, there are additional other things such as pool fires, where we've done testing, levees, again another quite a violent explosion mechanism, and runaway chemical reactions are all potential hazards that you may need to deal with. So once we've got an understanding of what hazards we're dealing with and how bad it can be, we can then look at what the impact of these hazards on our equipment, on our people is. This shows a jet fire test similar to the one we looked at before, but again this time it's directed at an ISO container that could be being used for an office, for a maintenance shed. So we can see the heat building up on the outside, and you can imagine the temperature within that container going up fairly instantly, and that was certainly the case. Looking at the front view where we've got a window, within a matter of seconds, the window's failed, and the flames are going straight into the container. So again, not good news for anyone who happens to be in there. So again, it's understanding the vulnerability of potential locations where people might be. So what can we do in terms of vapor cloud explosions? And again, if you want to go to the BakerRisk website or the BakerRisk YouTube channel, you can watch videos like this till your heart's content. This particular one shows the box to the left is our deflagration load generator that generates vapor cloud explosions of that we can control in terms of pressure, duration, and material. And then this is the impact on a pre-engineered metal building, so a metal frame with metal panels. So you can see here although the frame hasn't really moved, the building hasn't collapsed, there's significant damage to the cladding, and the debris flying within that building would pose a significant threat to any building occupants. So looking at a similar, this is a similar test again on a blast resistant module. Again, from let's just run the video and then I'll talk you through it. So again, this shows the impact inside the building, and although there's some distortion to the actual container itself, it's pretty minimal. But you can see the impact of the fixtures and fittings flying around, and obviously anyone who happened to be sitting at that desk is going to be having a fairly bad day. So we've identified what can go wrong, what can be the potential impact, and then, well, okay, so what can we do about that to help reduce risk and improve the situation? This is just one example. We can see here on the left. This is a wall section. This is our shock tube that is designed for testing construction units. So that first test shows an unreinforced concrete masonry unit wall exposed to what's probably quite a low exposure, but there's absolutely no blast resistance in that structure. If that was a load-bearing wall holding up a roof section, that would fly out, the roof would come down, and obviously anyone within that building there would be very high vulnerability to any occupants in that building. So we move to the right-hand side, and this is what is a fairly cheap and simple solution to just put some reinforcing rods down through those concrete masonry units and grout them in. And you can see there that there is damage, it does flex, but it doesn't collapse. So again, if that was load bearing, then the roof would stay in place, and you've got much improved occupant vulnerability. Again, this is just one example of many potential ways to upgrade buildings to make them more blast resistant. One point to make in terms of definitions: you're always improving blast resistance. It is virtually impossible to design something that is blast proof. Blast proof implies it is resistant to any potential explosion, which is not the case. So we're always careful to use the phrase blast resistance rather than blast proofing. And just to finish, Wayne had mentioned earlier the Fortress business, which BakerRisk has started in fairly recent years, and this is around using reinforced concrete modular buildings to provide that protection, multi-hazard protection for building occupants. In the picture here, you can see there's the test rig, the load generator rig on the left, and then there is a Fortress reinforced concrete module building in the foreground, and behind it a steel blast resistant module and we'll show some internal views as well. I'll just run this video. So instantly you can see how the blast resistant module is pushed back, whereas the inertia of the concrete one held it in place. And then the internal view. So again, the inertia of the concrete building avoids that that violent movement that we can see in the internal of the steel building, where the occupant is likely to be damaged by the movement of the building or the dislocation of the fixtures and fittings, whereas the guy safely tucked away in the fortress building that hasn't even spilt his juice. So you can see that that's an example of a solution to an issue. And again, you could then put that building in a position where perhaps you couldn't put other buildings and still control your risks adequately. Okay, with that, I'll hand over to James, who's now going to talk us through some of the challenges of implementing a PSM program. Okay, James, thank you.
Brilliant, thanks, Rob. And thanks for that background, which reminds us all of the hazards that we face with our plants. And really, to move this forwards, the standards, the Egyptian PSM standards, as Wayne mentioned, are an absolutely exemplary example of the best practices gathered from around the world. A real achievement putting those together. Now we have the challenge to actually implement them. How do we climb that mountain? And that's what I'd like to talk about now. So the question we all have is, well, where do we start? The Egyptian PSM standard, I'll talk about its structure a little more in a few minutes, but it has two key components. It has pillars, which are the foundations, and the elements, which are the individual standards. But it's important to remember this is a journey. Full implementation of this takes a long time. For most organizations, a fully mature process safety management system can take several years to put in place. It's an improvement cycle. But the fundamental here is the foundation upon which we build. That, if it's going to succeed, has to be led by a strong leadership commitment. It's a big task, but I think it's important to remember that I think there's a saying, whatever the mind of man can conceive and believe, it can achieve. It takes time, it takes effort, it takes focus. But as I think Rob demonstrated, the benefits to safety, to the environment, and to our business are very considerable. So really just to focus on that for a minute, the role of leadership is to lay the foundations. If we build a house upon the rock, it will stand strong. And that's the important thing at the beginning of this process. A deep, strong commitment from the top of the organization, from the leaders in the organization, will propagate down, will influence the people through the management, the supervision, the operators, to take this seriously, to give it the consideration it needs. And I think it's important just to remember there are three questions we should all ask ourselves. We know we have hazardous chemicals. We know we have hazardous processes. We should always know what is there that can cause us harm. The next point, going back to Rob's process safety cycle, is in which case, what is going to protect us from that harm? You know, I think a lion in a cage is still a lion. But if we put the lion in the cage, we are managing that hazard. So we have to understand what are the barriers, what are the safeguards that keep us safe, that keep our business safe, that keep our people safe. And then the final question, which we must never forget, is how do we know that those safeguards are going to work when we need them? And this is where a term you may have come across is so valuable, is chronic unease. It's a reminder that because these hazards are present, we can never forget them. We can never take our eye off the ball. We must always keep checking that those hazards are under control. Because if we become complacent, if we become overconfident, that we say, well, everything is safe, we're protected. Everything that man builds is not perfect. So eventually something will happen. And a lot of the videos that Rob showed and the images of previous disasters have occurred when people in an organization have stopped worrying and said, oh, everything's safe. So that really is the message I want to put at this point, that leadership, that feeling of chronic unease is so important. So what I'd like to do now is go on to the actual structure of the process safety management system.
Excuse me, James?
Sorry, Wayne.
Yeah, there seems to be a little black box showing up in the lower right-hand corner on the viewers' screens. I don't know if you're seeing it as well.
Not on mine. Joanna, can you see anything? I'm getting some thumbs up animations coming up, but I've got nothing else showing.
Yeah, it is showing up, and I know there have been a couple of comments.
Okay.
Yeah, I can
Rob, are
see
you
it.
seeing it as well?
Yes, I'm seeing it. Yep.
I'm
Okay.
seeing.
I've got nothing showing on here, unfortunately. Joanna, any suggestions or?
Yeah, it's on, it might be on your screen, James, view, maybe your panel, participant panel, or just check that.
I know you've got some graphics coming up later, and that box might interfere with it.
It may, yeah, let me just try running this through. Maybe the animation, Joanna. Let me just try that and see. If not, I maybe need to swap screen sharing, start again. Let me try this. I'm sorry, everyone. Let me just continue for a second.
Sure. Thanks, James.
So very often the model that's used to visualize a process safety management system is that of a temple. It has a foundation at the bottom. It has vertical elements that hold up the roof, and the roof is in fact the system, the business that we support. And the Egyptian PSM model describes these as two types of components. The bottom, we have the pillars, the foundations, and these are, you know, the fundamentals if the system is going to survive and grow. And then above them, we have the elements. And these are the individual standards which are so well set out with the Egyptian PSM system that hold up the roof, that hold up the building. Has that dealt with our problem, Joanna? Have we still got the issue?
We still have it.
Okay. Is it worth me dropping screen sharing? I'm just nervous about doing that midstream.
I
Okay.
suggest we just continue, James, because yes, just continue. Thank you.
Okay, so let's just look at this now in terms of how do we implement this? We have a model, we have a great deal of detail, but how do we actually deal with the main problem that we face, which is how to implement this? So first, let's look at the structure we have. If we take away the detail, we're left with the foundation pillars: the commitment, the understanding of hazards and risk, the management of risk, and learning from experience. And these are so critical because they actually form the improvement cycle that we need in any management system. So the first one, the commitment, we've spoken about. This is the cornerstone. Vitally important for any system to have leadership and commitment. If we have that, we can provide the resource, we can provide the focus to understand the hazards that we have, to understand the risks that they bring to our business. Because if we don't know about a hazard, if we don't identify that hazard, we cannot manage it. You know, we look back in history in the case of the Titanic, the ship that sank in the North Atlantic with huge loss of life. They didn't see the iceberg as a hazard, and yet the iceberg destroyed the ship and caused huge loss of life. We have to know about the hazards if we're going to manage them. Once we know about a hazard, then, as Rob demonstrated in the process safety cycle, we can focus on managing them. How do we bring those risks down to a safe level for our business, for our people? And finally, we have learned during that process. We have discovered, we have assessed, we have analyzed. To improve, we must learn. And that is what the first three pillars give us, is that information to learn from. Any business which is going to thrive has to learn. So if we put these four pillars together, they provide a very, very powerful improvement cycle. We begin with commitment. We understand the hazards and risk. From that, we know how to manage it, to keep our business safe. And as things happen, things will go wrong. But the important point is that we learn from them. We learn far more from mistakes than ever we do from doing things right, even if it's a painful process. But that learning means we can go back and improve our understanding of the hazards and the risks that we face. And as we do that, it allows us to strengthen our commitment. We see that we're making our business safer, making our business better, and it allows us to strengthen that commitment. So that is the key cycle. And that is really what we want to talk about today, is starting this process. It takes time, it takes experience, it takes judgment. But this is the key to making any business stronger and safer. So how do we put this into play? All our organizations are different. As individuals, we are all different. So we have to consider that in how we make our plans, how we set our priorities. So we need to ask some questions. What is our safety culture now? Is process safety management a new thing to us? Is it something that we already have experience of, that we're learning? And what is the shape of our organization? Do we just have one site making one product where everything is hopefully under control? Or do we have many different sites, and do they make many different products? Some may be more hazardous than others. So we will have to accommodate that in our system. And a very important question is, how old are our installations? In my operating experience, I had very few opportunities to build a brand new plant. I had plants that were built 10, 20, 30, 40 years ago, and I had to manage them safely. And I couldn't just demolish them and start again. So we have to think about those questions to set what we call the context for the organization. What is going to be right for your organization before we begin to build the detail? And an important point of that, what is the culture? What are our beliefs? What are our approaches to process safety? And this is talked about a lot. And there are definitions from CCPS. The one, I must admit, I always refer to is one that came from the Energy Institute Hearts and Minds program. And this developed after the Piper Alpha offshore disaster in the North Sea in the UK, which said, you really understand the culture, the safety culture of an organization when you see what happens at 4 o'clock in the morning when no one is watching. What are the true beliefs of the organization? And it's important to remember that those beliefs are always set by its leaders. So developing this, and as Rob mentioned, coaching this, explaining how to make the right decisions at the right time is so key on this journey. This is how we set up what we're taking, how we're traveling, and what really matters to us. And if we look at that in a little more detail, these are probably the main take-home points. For an organization to learn, it needs information. It needs to understand what went wrong. So we need people to bring forward the incidents and the accidents that have happened so we can learn from them. And there's a degree of trust to do that. In some organizations, people are frightened to say they've had an accident or they've seen something wrong. But we miss a learning opportunity there. We need to know about the bad things so that we can fix them, so that we can prevent them happening again. We want to learn. An organization that learns will adapt, it will grow, it will thrive. And we come back to this question of chronic unease. If we're always checking, if we're always just a little bit worried, we will make sure everything is working correctly. And that saying of, if you're not worried about something, you're probably missing something, is probably the key learning point here. We base our decisions on information, on data, on expertise. And this is an area where we're always happy to help. Many of our specialists have had many years in industry, operating hazardous processes, seeing what has happened when incidents, when things have gone wrong. So understanding the culture of the organization is so important in shaping how we implement process safety. And then just to come to the last point that I had on that list. I'm sorry, I've missed one slide here. The range of hazards that we have, the range of processes, will set different requirements. And we have to make sure that we can accommodate all of that. And as we move through, then to my question earlier, I only ever had one new plant in my 35 years in industry. That was much easier. The old plants were far harder to deal with. And this is data from the insurance industry, looking at where the financial losses occurred. And they occur most at the beginning and at the end. That is what we often describe as this curve, a failure curve. And in some ways, it reflects human life. In the beginning, a small baby has many risks. And then hopefully we grow into a strong person. Our life is productive. But at the end, we become old, we become frail. And we have to be aware of these three stages. And they apply to a chemical plant. In the beginning, we are learning how to operate the process. Our operating teams are learning how to write safe permits, how to follow procedures, how to make sure that the workforce are involved and understand what we have to do to stay safe. And over time, we learn. That very important point about the organization, learning. And we move into the mature phase. And here, we have to focus on remembering what we have learned, not becoming complacent. Just because everything is okay doesn't mean it will stay that way. And then finally, and this is the battle that many of us face, our plants become old. We try to extend their life. Very often, mechanical integrity becomes so critical here. There can be a significant amount of the failure case. Management of change, where we make changes to keep our plant running without perhaps considering some of the consequences. So we have to consider the age, we have to consider the processes we run, we have to consider our business requirements if we're really going to implement process safety in a way that will work for us. So I hope that gives you a few things to start thinking about, pardon me, for your journey with process safety. So with that, Wayne, if I can pass this back to you to summarize and wrap up for us, please.
Yeah, I think, Rob, were you going to?
Yeah, I'm just going to dive in here for a couple of slides. Yep. Okay, so in terms of the path forward, you know, have you given me control, James?
Sorry. Yes, you should be okay now, Rob. If not, shout and I'll move it.
There we go. Yeah. Okay. So very often the people will refer to the sort of development of their process safety management system as a journey, and that analogy is pretty good in terms of a starting point, an end point, and a map that gives you gives you a direction, gives you the information to allow you to get from your starting point to the end. So obviously the first thing is, and we've said about the Egyptian PSM guidelines, the standards and guidelines, and they, they provide a very strong map. They set out what the what's required, what the expectations are in terms of methodology, resources, skills, competencies are clearly laid out in there. But obviously, you need to know where you are on that map, and so that would be our recommendation on where to begin, is to first of all understand where you are, and that may be through performing some sort of gap analysis or an audit against the requirements of the system, and then once you know where you are, you can based on many of the factors that James said about what do your operations look like? Is it multi-site? Do you have lots of different processes? Lots of different teams will dictate how big or small, or what levels of procedure and you need to ensure consistency across the organization. So again, once you know where you are and what it is you're trying to drive forward to, then you can set out that that journey. And again, it may not be instant. It certainly won't be instant. It may take several years, and but it's understanding what you're doing and the logical sequence. We've had many examples of similar standards implementations, and someone will see, oh, there's a requirement there that we must do a HAZOP, and a request will go out, oh, can you come and do a HAZOP for us on this plant, when clearly the understanding of to do an effective HAZOP, you need to make sure all your information is correct, it's up to date. And so there are several steps before that, and it's this broader understanding of where you are and what are the logical sequence of events to get the benefit, rather than just going through a tick box. We need to do a HAZOP, we've done a HAZOP. If you've done that based on out-of-date information or inaccurate information, or involve people who don't have the understanding and knowledge of the plant, then the output is probably likely to be of minimum value and will not help your journey to your risk reduction. So again, it's that understand what it is you're trying to achieve, your starting point, and then you can build that program which will allow you to achieve the intent of the standards and guidelines.
Yeah, very true.
Okay, Wayne.
Okay, thanks, Rob. I'm trying to move it to the next screen. There we go. All right. So as Rob was mentioning, it's more than just checking off a box on a checklist. And these are all the various aspects of process safety, that come into play, starting at the very top with process safety management. And I think you've seen that we really do focus a lot on the management, on the leadership, having that initial buy-in. That is so critical, rather than just having a checkbox. So we really want to focus on the leadership when it comes to the implementation. And that's really where it starts. All these other aspects are various studies that are, of course, done, but you have to do it in an informed way. And as I mentioned earlier, everything that we do informs everything else that we do. So all the problems that we encounter, whoops, sorry. All the problems that we encounter when we're on a site go back to our providing solutions, and it just continually informs us. We're very big on feedback loops, and I think you'll start to see that on a regular basis if you're working with us. James, do you know which way we have to go here?
Sorry, Wayne. Yes. Let me just take you back one slide for a second.
Okay.
Really, again, we're just simply recapping here. As Rob said, the PSM implementation guidelines is the map. This is the long-term view of how to move forward. The important thing being always just keep looking over your shoulder, checking, is there something out there we haven't missed? Is there something out there we must learn from? And so really with that, Wayne, I think it's over to you if you would like to wrap up for us, please.
Sure. All right. Is that the right slide that we're on now?
Yes, I think that's just as an overview, and then we're ready for questions.
All right, thank you. All right, first of all, so we apologize about the little box which is still showing up. On my the last few minutes, I also had some other boxes popping up. So clearly we've had a little bit of some technical difficulties. I apologize to everybody viewing it. Hopefully it hasn't disrupted it too much for each of you. I will point out that we are going to, for all of those who are on the event right now, we are going to send this out as a PDF for each of you. So you will have the entire deck sent to you. Later on. We will have to remove some of the videos because some of those videos are proprietary to the ERC Explosion Research Cooperative Joint Industry Program that we run or facilitate. Some of those videos are proprietary to them, so we have permission to show those, but we don't have permission to share the videos. But you will certainly see the photos with it on a PDF, and we are going to send that out to each of you. So you'll have that for your reference in the future. And again, our apologies for the technical difficulties. It seems like no matter how many dry runs you do, there's always something that will pop up that, you know, we didn't want to spend the time trying to fix it while in the midst of a presentation.
Is that chronic unease, Wayne?
Yes.
You know,
yes, I'm feeling that. I'm feeling it. Right? Yes. So I'd mentioned feedback loops a couple of times, and we do that professionally with everything that we do. We're also going to request it as part of this webinar. So after the webinar, we're going to send out a survey to each of you, not only to, you know, about the content and about this webinar and the presenters, but also what we want to do is hear from you about what topics you want to hear for the next few webinars. Rather than us dictating what you should hear, we tend to be better at listening than we do at speaking, and we try to listen and address the needs. So we really do want to go ahead and hear what it is that is of utmost importance to you, what you want to hear about. This is new for some of you. We have a variety of different roles and people and levels of professionals on this webinar right now. So you'll have differing viewpoints, but we want to hear what those are. So please, when you get the survey, send us what your interests are for the future webinars, because this is going to be an ongoing series, and we want to make sure that we're addressing your needs. We are going to try, I know there's quite a few questions. Some of them are somewhat detailed. We'll try and address some of those here today, but what we're going to do so that we address every single question, and even though it may not be on this webinar, is we're going to answer each question separately and send out an answer to each question to all the participants. So for any question that was asked, you're going to see all the answers, or for every question that was asked, you're going to see the answers, and that'll go out to everybody as well. We may, assuming we have no technical difficulties with this, try and do it in a video format. So rather than a written format, you'll see us on screen asking the questions and then going ahead and answering them on screen as well. So we're going to see if we can get that out to you as well. This webinar was recorded, so you'll have a link to it, I believe, afterwards also. If you want to view it again, see a particular part of it, that should be available. And that's it. We are going to be at Egypt in February, so we hope that you'll come by and see us at that point. Rob won't be there, James will be there, I'll be there, a few other team members will also be there. But you can also look at our website. Feel free to reach out to us with any direct questions as well. As it says, we're here to help. And same reason as you, we're here to save lives, make the world a little bit safer for everybody. So with that, Joanna, I believe you have some questions that you've been looking at.
Yes, thank you so much for that, Wayne, James, and Rob. Well done there and giving us some information. I have a few questions that's come up during the webinar. First one, when will the next webinar be, and what are the topics going to be? And I think Wayne did speak on that.
Yeah.
But if you'd like to just reiterate that, that would be great.
Yeah, I'm thinking it will probably be after Egypt's 24, so probably 3 months, 3 months down the road. This webinar, by the way, so we attended in February of 23. Rob and I started talking about this webinar right after that in March of 23. And then Rob and James and I really started putting the whole thing together, I'm going to say in May. And it's taken quite a while to kind of get some feedback in the interim since this was the first one. Took us a while to get it all together, and we finally got it out now in December. So while this one took, you know, half a year to get together and get out there, we're hoping that the next one will take a little bit less time. So I'd probably say at the end of the first quarter in 24 is what we're going to shoot for.
Brilliant.
If I can come in there, we're already seeing in the Q&A some ideas from you guys on what you'd like to see in those subsequent webinars. So the PSM gap assessment, so that first step on understanding where you are, seems to be of interest, and then again relating to aging facilities, the asset integrity management systems, some additional information on that, and safety critical elements, identifying and managing safety critical elements, safety critical systems. So again, some ideas coming through already that will help us focus our offerings going forward. Thank you.
Thanks, Wayne and Rob. I have another question that's come up. What is the normal timescale for implementing PSM at a site?
Do you want to speak to that, Rob? Would you like me to?
You'd mentioned it that it's probably years rather than weeks or months,
Yeah.
in terms of maybe getting that plan in place, and then working through. And a lot of these, well, once you get that clear vision of where you want to be, and these many of these activities are on a cyclical basis. So like the process hazard analysis, quantitative risk assessment, the sort of best practice around the world is that you review and update that on a sort of 3 to 5 year cycle. So there's a sort of cyclical nature built into the process. But I would say it can take to get perfection. Well, I don't think you'll ever. You will always find something that you can improve.
Chronic unease, yes.
But yeah. But the key. The key basics, the key building blocks of a PSM program, I would have thought 2 to 3 years you could probably nail 70% with a reasonable level of confidence. Identify what the remaining 30% is, and where you need to go back and refine what you may have done initially and thought, oh yeah, we could have done that a bit better. So it is. James said it's a learning process as you go through this.
Yeah.
Well, I would say 2 to 3 years to be able to say yes, we've gone from nothing to having a management system and clear demonstration that we are implementing that management system to manage and reduce our risks.
Yeah, I'd agree with that, Rob. To me, the one that finally tests your system is when you go through a full turnaround. because that's usually, for most of us, an unusual situation, and that's a good way of proving your systems. You will learn things during a turnaround that are relevant to your process safety management system. So you can then go back and build those in. So yes, two to 3 years to get something pretty good in place. Once you've been through a full turnaround cycle, you'll probably bring that up into the 80%. And after that, you're always just looking for improvements.
Thanks, Rob. Thanks, James. One final question. What are the key elements of an effective PSM system?
Okay, let me just take that one. I'll just see if I can jump back to an earlier slide that we had. May just need to move back. Sorry, without scrolling all the way back through the slides, let me just mention back to the model, the temple structure. We talked about the foundations. In the beginning and the early stages of a process, the key commitments are to process safety, to safety culture. Those two elements are very important in the beginning, followed very swiftly by process hazard analysis, quantifying and understanding the hazards that we have. And if you think about that model of a temple, we need the elements to support the roof, but they must be spread across the whole area of the roof. So once we have that commitment in terms of process safety, of safety culture, and then hazard identification and assessment, we're looking at the necessary steps to manage risk. And that might be knowledge management, it might be mechanical integrity, and finally the management review. And I think you're probably talking about somewhere in the region of those 5 areas being pretty critical to getting the system away. Over the successive years, then we're looking at reinforcing by bringing in the other elements. But it's always important to look at the history, to look at areas where perhaps you've had incidents, or in the wider industry that you work in, you've had incidents, and asking the question, how would those have been prevented? And more importantly, how do we prevent them here? So you're probably talking, once you've made the initial assessment, of focusing on perhaps 5 or maybe 6 elements in the early stages. And as Rob said, that really is the value of the gap analysis. Finding out where you are, where you stand. Do you stand upon rock? Do you stand upon sand? That you then can focus, because you can't do everything at once. So I would say they're the main areas to begin with, once you understand your position, you know, the gaps that you have. Do we have anything else on the list, Joanna?
As a matter of fact, one more just came in. This question says, what's the impact of MSDS on process safety? Maybe you can speak to that.
Yes, it's a very good question, because the further, I'm speaking from my own experience here, the further along the process safety journey you go, the more you realize that often the information in an MSDS, or a safety data sheet, as they're sometimes called, is probably not everything that you need. While the sections for an MSDS are generally laid out, the depth of information is not. And if you're looking in the physical properties section, there may or may not be information in there that tells you some quite important factors, like, could this material be a dust hazard? It might tell you that it's flammable, but it probably doesn't give you exact limits of flammability or the energy needed to ignite it. Again, on the toxic side, it may give guidance, but it may not give the information you'd need to model. So I would say, in my own experience, very often as you progress through implementing a process safety management program, you will have to seek out more information than perhaps your suppliers are in a position to give you. So whilst it's important to have MSDSs for all the materials that you're handling, again, coming back to the point of chronic unease, don't ever believe that the MSDS is everything or that it's totally accurate. Always have that little question in the back of your mind. What of this must we check? What of this do we need to verify? So yes, they're important to have, but just be aware that the content and the detail in them can vary quite significantly. If that covers the question.
James, much appreciated. I have another question that's just come in. What ensures the success of a management of change process?
Do you want to take that one, Rob, or shall I?
I'll take a first stab at it, and again, I'll give the obvious answer that the first step is management commitment. That without that, any of these processes, and particularly management of change, is one that is particularly challenging. And I would say what ensures success is making sure that you have a good, solid process for reviewing changes that allows you to filter which changes need different levels of assessment. It's very easy to write a big long procedure saying this is how we'll analyze each and every change we identify. If you are applying that to insignificant or very minor changes, people will quickly get disillusioned and lose value and work around that procedure. So I would suggest if you need some sort of grading process that defines what the nature of the change is, and then from that, what level of assessment there needs to be. If it is for example, if it's an important change like a change to a material that you have in your process that has different toxic or flammable issues, then that could be significant. So you might want to then do some sort of HAZOP type review and maybe some sort of risk analysis as part of the management of change process. Whereas others typically changing kind, where you're changing something for something that is the same, would not need that same level of rigor. And the other thing that is very common failure in management of change processes is the failure to close it out. So you go, the change will be designed, reviewed, implemented, but then the closing step of updating all the drawings and all the information to make sure that your piping instrumentation diagrams, your relief schedules, your cause and effects, all those key process safety information documents reflect that change. It's far too common to go in and audit an organization and find that they're poor in closing out that bit because people's interests have moved on to the next change. So I would say that getting some discipline around closing out each change as you go through the process.
Yeah.
Joanna, if I can pop in real quick here, we've got a lot of questions coming in. And I don't think there's any way we're going to get to some of these right now. And some of them are fairly involved, so we're going to have to take a little bit of time. We will include all of these on our Q&A that we send out afterwards. So everybody will get all the questions that were asked and of course, all the answers. But I have one final question I wanted to throw out right now to Rob and James, and that is there an order in providing different PS studies? And if so, and I think this goes back to the circular chart that we've shown a couple times. So if there is an order, which would come first? What's an ideal order?
I would say, yeah, that we mentioned it earlier in terms of the once you've got your systems in place to say what you're going to do, then the logical sequence would be to go through a hazard identification exercise, so you truly understand what the different types of lions you have in the cage.
Yes.
And then an analysis of those hazards to determine how bad it could be, what the impact would be in terms of risks to people, plant, environment, and then so the hazard identification, hazard analysis and quantification, risk analysis to identify where you need to focus your efforts, and then start looking at options for further controlling and reducing that risk. And then you're back into the cycle then of, well, we've made these changes. What has that done to the risk profile? Let's just make these adjustments to see what our current risk profile looks like.
Yeah, and I think the one point that has been made very clearly that you've both made is awareness of what the problems are. First and foremost is doing the audit, understanding what you have to deal with, and from there you can go ahead and get a plan implemented. Mm-hmm. But it all starts with awareness, identification.
Yeah,
very good.
And commitment. It also, if you've not got the commitment from the top level, then you're fighting a battle every day.
Yeah. Yes, and that ties into budgeting as well. But that's that's a topic for another webinar.
Yes. Yeah.
Yes.
Yeah.
Well, I think very good. I think we're going to thank you, first of all, for all the questions. I'm looking through them, and there are some very good questions in here that are going to take us some time to really clearly answer, and we will get those out to you. As I said, at least in writing, but ideally in a video format, so you'll be able to view the Q&A that way as well. We are going to send everybody the PDF of the entire deck, of the entire presentation, so you'll see that. And I think that pretty much wraps it up. So on behalf of James and Rob and the rest of BakerRisk, thank you very much for your attendance. We look forward to your feedback. We'll get a survey out to you, and we'll also hopefully look forward to seeing you again in February and at our next webinar. Joanna, do you have any other closing comments?
The only comment I have is that you will get the survey as soon as the webinar ends, and if you could kindly complete that for us and send back, we would appreciate all the feedback we can get, and so that we can prepare for the next one. That's it.
Very good.
Thank you, Wayne.
Thank you, Joanna. Thank you again to all the attendees. We very much appreciate your interest in this, and certainly look forward to the feedback, both good and bad. Thank you. Have a great day. Be safe.
Thank you very much.
Thank you, guys.
Take care. Take care.
Bye.